Hello, everyone, and welcome to Women in Data Science Subotica 2020 online edition. I promise I am the only man you're going to see tonight. We are very proud to host the WIDS Subotica Online 2020. My name is Željko Crnjaković, and we are InfoStud Hub. This event should have been done live in our main hub and events hall, but due to the pandemic, we had to move it online. So we are here for you with 5 amazing talks and some Q&A sessions. So WIDS is basically a conference that started at Stanford in November 2015. Since then, it grew to a worldwide conference, including 150 regional events. Let's check out the welcome message from WIDS.
Data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that the data can provide us is just growing exponentially, and that is no exaggeration.
The market for data science and related areas like AI is booming.
It is so important to have women in artificial intelligence, in the area of data science, and also in leadership roles. It's being able to use data to solve issues and understand bigger problems. It's critical. And we need women in these roles. Every individual brings their own perspective, and so we need to make sure the entire workforce is represented.
And the good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really, really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social and structural problems. We can't just go in a corner and write some code and read math and then that's the solution, right? Can't do that. So we have to think about who is being affected by these algorithms.
Welcome to WIDS!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WIDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WIDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WIDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show. And And now outreach to middle school and high school has just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had a profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WIDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
Wow. So we know what WIDS is. So let's talk about our event. Our event is WIDS Subotica 2020, this time online, and it's happening for the second time. And it couldn't have happened without the help of our main organizer and WIDS ambassador, Tatiana Ketsievich, who is a data scientist with a doctorate in statistics from the University of Manchester. Tatiana has been really a mastermind in pulling together the entire women in data science community and data science communities, and doing a lot of work with courses in R and statistics and data science and a lot of things. So I want to introduce Tatiana like this, and I also want to play you her welcome message. But before I do, I want to remind you that this is a webinar. You have a live chat. And please, during the presentations, which will start after the next session, so once we introduce the main speakers, please ask questions, and we can note the questions, and we'll have the speakers live here with me, so I can ask them your questions after their presentations. So at any point, you can ask. You can just put your question in chat, and I'll mark it, and we can ask the speaker there. If you have a bad connection, please remember to just refresh your window, and hopefully you'll be connected back. So here's Tatiana with her welcome message.
Dobar dan. As a Women in Data Science ambassador, I welcome you to WIDS Subotica 2020. My name is Tatiana Ketsievich. I'm a data scientist with a doctorate in statistics from the University of Manchester. I have spent many years working in the UK university sector as a senior lecturer. I am the founder and director of Sister Analyst, an organization aiming to empower women from a diverse range of backgrounds through data literacy. In addition to my involvement supporting women in STEM-related activities, I am dedicated to creating an inclusive culture by developing initiatives supporting all underrepresented groups within the data science community. The Women in Data Science initiative aims to inspire and educate data scientists worldwide, regardless of gender, and support women in the field. WIDS started as a conference at Stanford in November 2015. Now, WIDS includes a global conference with over 150 regional events worldwide, including a datathon, encouraging participants to hone their skills, a podcast featuring leaders in the field talking about their work and their journeys, and an education outreach program to encourage high school students to consider careers in data science, artificial intelligence, and related fields. Our event features outstanding women within the data science community. WIDS Subotica welcomes anyone with an interest in data science. Our goals are to promote data science, exchange knowledge, and create a data science community among women. We are fully inclusive and respectful of LGBT identities and welcome anyone interested in the field of data science. Due to the situation regarding COVID-19, we had to move our event online with a program containing 5 presentations by outstanding women directly engaged within the world of data science. The talks will provide an opportunity to hear about the advances and research in the number of data domains, learn how leading women in data are advancing, and connect with potential mentors in the field. But Before we begin, I would like to thank, first of all, you for joining us this afternoon and for supporting our initiative. But most of all, our big thanks goes to our amazing presenters. Agnieszka Kaminska, who, with her background in cognitive neuroscience, will talk to us about building an efficient data processing pipeline with a focus on the critical importance of feature pre-processing using the example of human brain research. Željena Grbović will tell us how data science and in particular deep learning technique can be used in farming. Buena Soro will illustrate the application of data science in digital publishing industry by the possibilities of monitoring content performance through different dimensions using machine learning techniques to gain some valuable insights. Tijana Blagojev, as an R enthusiast, will focus her talk on the application of programming in R for media policy development. Finally, Maria Nobes will explain to us challenges of small data, from gathering data in a unified way and data cleaning to ever-baffling challenge of modeling sparse data. I take a positive view that current situation will push for data-led social evolution by forcing for digital governance that facilitates developments of the healthier, safer, efficient, in other words, more democratic societies. Data, the lifeblood of our new global life system, is the key resource for addressing the big global challenges of today. Now, more than ever, data literacy should be treated as a crucial skill for pretty much everyone. That doesn't mean everyone needs to become a qualified data scientist. Only by empowering people at all walks of life, regardless of technical acumen, to become more data literate, we can deliver greater innovation, transparency, stability in market behavior, and improved social outcomes. Data analytics provide unprecedented instrumentation for how policies are performing so they can be quickly adjusted. Embedding those principles into a working global life system that is equitable and inclusive will take time. Nonetheless, with this pandemic, there is a growing awareness and consent on the need for data-driven societies, countries that are resilient, build upon the dignity of individuals, extraordinarily transparent and fully accountable. We believe that by connecting women data enthusiasts, discussing ideas and formulating outcomes, we contribute to a shared desire to resolve many of the challenges we face as human beings. And I hope you will enjoy being part of this process. At the end, I would also like to take this opportunity to thank Data Science Serbia community for their encouragement, and in particular, special thank you to our partner Infostud for their amazing support. Wish you all to enjoy this event.
Well, that was a nice intro, and thank you, Tatiana. So, before we get to the live Q&A sessions, we need to hear some things. So let's introduce our first speaker and get to the main event. So our first speaker, as Tatiana said, is Agnieszka Kaminska, who is a data science enthusiast. In her everyday work, she combines analytical and research skills with machine learning knowledge in order to provide new solutions for product analysts' purposes in OLX Group. With her background in cognitive neuroscience, as Tanya just said, she will talk to us about building an efficient data processing pipeline with a focus on the critical importance of feature pre-processing using the example of human brain research.
Hello, everyone. My name is Agnieszka Kaminska. I live and work in Poznań, in Poland. And today I'd like to discuss the topic of feature processing and its importance in data science workflow. So let me start from short introduction. By profession, I'm product analyst working in OLX Group. And during my everyday work, I try to find data scientific solutions for making our product, our platform more adjusted to customer needs. By education and by passion, I am a cognitive neuroscientist, and this is why I decided to use one of my side projects to show the bigger picture for the topic of today's talk. Very important part of my professional life is being a part of a global organization, the Women in Machine Learning and Data Science. I started the WIDS chapter in Poland to connect with other women, but also to support people who are identified as minorities in the field to cooperate, share knowledge and experiences, support each other. Feel free to reach out to me after the event if you are willing to discuss the topic. Right, so what is feature processing? So in brief, it's a process of selecting, transforming, and cleaning a given data source. Yeah, that's this more boring part. But what is exciting is a case when we are able to add some new relevant information and create new variables based on the domain knowledge. And you might say, like, hold on, I'm a data person. Why are you talking about domain knowledge to me? So yeah, this is actually why I wanted to talk about this particular topic today, because the more different data and project I work with, the more I'm standing on the position that this is a very crucial part of the whole process to try to at least understand at basic level the problem which is behind the data we are working with. In majority of business projects and many research projects, the ultimate goal is to get interpretable results. So if we put some effort and take some time to create or select features enhancing this final effect, it's definitely worth investing it at the initial stage. But sure, we need also some more practical arguments. So by avoiding redundancy among our features, we can easily reduce computational costs that are associated with the project. And for production context, it's more time efficient when implemented model is less complex, and for example, for online stream processing, it's also the performance issue. Now, a few words about the project. We were lucky to take part in this challenge, and I mean access to thousands of brain scans, which is a completely untypical situation in neuroscientific research when these experiments usually are very expensive. So researchers end up with pretty small data samples. We, and by we I mean the team we met during the weekend-long hackathon, decided to take part in a global neurocognitive prediction challenge. And the task was to try to predict fluid intelligence score in children based on brain scans. More precisely, we had two types of data types for use. It was image of the brain itself, and also information about volumes of particular structures, because there are many individual differences among people, and this is kind of enriching information. When it comes to fluid intelligence, let me briefly explain what is meant by this psychological term. So fluid intelligence is derived from human cognitive abilities theory, where the general intelligence is differentiated by its developmental origin. So crystallized and fluid intelligence. And the former includes acquired intellectual skill set, which is connected with education and socio-economic background. While fluid intelligence describes some general abilities like pattern recognition, abstract thinking, and problem solving. So it's more associated with inborn biologically based features. These colorful sections of the brain you are observing here reflect anatomical division from the standardized atlas we were using. And in short, this is a way of normalizing data from a spatial perspective. An interesting idea of challenge organizers to minimize confounds was to residualize raw scores of fluid intelligence by the data collection side, socio-demographic, socio-economic factors, and the total brain volume. What is worth mentioning, we had over 8,600 brain scans used, but for the whole challenge, but over 4,400 brains were unseen by the model, and they were used for final evaluation of it. So now you have a general idea how non-brain factors were excluded from further processing. Some highlights of the project. So we did a brainstorming session, and we came out with a pretty long list of new features we would like to create. But due to the time constraints, as it was a weekend-long event, we decided to select few of them, but each was providing different kind of information. When we discussed the model we would like to use, we knew that there is a trade-off, and we can invest more time into tuning key parameters of convolutional neural network, for example, or use a more simple model like regression, and to concentrate of selecting features. Why we decided to choose it? Because we knew from literature that only up to 20% of predicted variance when it comes to measured intelligence can be explained by anatomical structures. So we used MDA algorithm to calculate feature importance. Mean decrease accuracy algorithm is not very common, I guess, because it's not explicitly implemented in scikit-learn, but it's pretty handy. It takes samples from the validation set and iteratively replaces each of its features with a random noise to check how the performance changes when a feature is distorted. So the method's output is a weight for each feature that indicates its importance for the model's performance. So basically, this is how we collected our whole set of features, just in case you're curious what kind of additional information we added. For example, we knew that different parts and different tissues in the brain contain varied amount of water, what can be measured with a MRI signal. So for example, by calculating entropy, we were able to have some kind of surrogate metric for assessment how much of the gray matter versus white matter we can find in a given area. So based on MDA indications, we chose 141 features. So our initial data set of over 540 ones were highly reduced. Yeah, I guess you are waiting for algorithms. We compared performance of 3 of them: support vector regression, random forest regression, and XBoost regression. And here you can see the results we obtained without prior feature selection. For competition comparison, it was quite typically used mean square error we were trying to reduce. And you may say that it's pretty high, and yes, you are right. But what's worth keeping in mind is that for this kind of complex data structure and very general hypothesis to test, because here fluid intelligence is a very internally diverse concept, which we are measuring with very simplified one score. This is something you can just expect to happen. So we knew that we were taking part in competition, and we have to take a risk of model overfitting by fighting to reduce MSE. In a way, we are able to do it. So after including all features selected, we were able to decrease MSE to a level of 67.39. And you may now say, like, hello, is it really a success? Well, it depends of your goal and values you are working for. When your dream was to see your name on a leaderboard, yeah, it was pretty successful. But when you keep in mind a broader context of explaining some phenomena we observe in research data, there is always a hunger for further explanations. So this is what I keep saying to myself when I'm digging into the data. So now you might think yourself, like, she is talking about some nerdy competition, and how can I actually apply it to my everyday business work? Actually, I think you can. Because most of business projects and many research projects focus on doing something better than before, being more efficient, being better than competitors. And if we all are having access to open source tools, from technological point of view, there is a lot of equality in this context. So the difference you can make is actually the way you are working with your data, the way you face the challenge, and the way how you understand the problem you're working with. So from this place, I highly recommend to take some time and try to better understand at least basics of the field you are thrown into with your project. Of course, kudos to my great brain hack team. And here you have some resources listed.
Okay, so we have done, and we have Agnieszka live with us. Hi.
Hello, hello. Thanks.
How are you?
Oh, I'm really great. Thanks for having me today, and I'm really happy that this event is actually live here. So
yeah, it's actually live, and we're having you live. So thank you for the awesome presentation and all the work done before the actual event. So we already have some questions, and everybody to all the viewers, just so you know, we have a limited time for questions. So we have about 8 to 10 minutes. So I'm going to get right into the questions. Agnieszka, why did you use MDA? Is it entropy based?
Oh, no. So the entropy mentioned here was referring only to the one of features we have generated. So it was the our idea to create some proxy metric for how much of gray matter in a given voxel, which is the equivalent of a pixel in 3D. How much of this gray matter do we have? Because plenty of research indicate that the more myelination there is, so this part of the neural tissue, which is crucial for transferring signal in a proper way, the better functionality of given area is. So, for example, for visual cortex, when you have high myelinization, in visual areas, the better performance of the cortex is. So that's why I mentioned entropy, and we chose MDA because we had hundreds of features, and we had some knowledge-based features, actually dozens of them to include to the model. So we wanted to measure the importance of features, and actually the cutoff was a kind of arbitrary because we based on literature just chose 75th percentile for this decision. And when it comes to MDA, why? Because also based on literature, it performs well with 3-based models. So we expected that we can accept the some consistency within performance. We could have more informative source of knowledge on why we are selecting those features. So actually, the weights calculated.
Cool. So another question: can you explain in more detail how the features were defined and how you made sure that they were independent? I assume they must have been in order to perform feature selection in the manner that you described.
Yeah. So actually, there is quite a lot of details on how we selected those features. So if you are willing to catch up after the talk, we can discuss it more, because plenty of them were of anatomical nature. For example, I didn't have time to explain more. For example, based on there was a picture of corpus callosum, for example. So we were calculating metrics for proportion of these parts among them. And when it comes to independency, we also tested all contribution of all features versus random noise.
Okay. And we have another question. So do you know where did the MRI pictures put in the model come from, and how were they collected?
Yeah. So there is whole documentation for this project, because as I mentioned, there was a huge initiative which was in fact a cooperation between plenty of institutions. So there were different scanners and different scanners parameters following the data acquisition. So this is very good point, because there are some studies suggesting that if you don't clean data and the noise coming from just scanner info. You can, and you run or simply run a classifier. You will classify brains regarding the equipment which was used for acquisition. So all of this information were described in details and were removed from the data set. Plus, there was this intelligence residualization used, which also makes it more relevant for the prediction process.
Fantastic. So, guys, if you have any more questions, we have only a couple of more minutes. While we wait for your questions, I'm going to ask one that I have right here. So, Aga, many women in tech struggle with some degree to imposter syndrome. So, have you ever felt as you were not good enough or technical enough to be where you are? And if so, how did you handle it?
So I must say I deserve this question, because when Tatiana reached out to me and asked if I can give a talk during this event, because she was so happy that they are organizing with Subotica, I said that, whoa, that's so great that you're doing this event, and I can recommend you great speakers. So that was my first answer. So for sure, it happens not only in tech but also in academia, and it's quite common. So to be honest, yes, sure, it happens to me as well. But I'm thinking more in a sense of this quotation, which is in Google Scholar, that you are standing on shoulders of giants. So this is something I keep in mind when I think about my work, that I'm developing something which is so I don't know. We have some kind of treasure we have to take care of, right? Maybe it's too poetic, but and to answering to the second part of question, how do I handle with that? Actually, I would say there are two aspects of it. So first, I'm trying not to compare to others, but to myself from the past. So I guess if most of you look at your code from, I don't know, year ago, or to some old projects or to some old presentations, you can notice a progress. So this is something that keeps me motivated just to be better than yesterday and to reach farther. And this is one thing. And the other is to keep surrounded by people from community who are great experts, but are also very friendly people. And it might sound trivial, but for example, I know people who are better than me from at some point. And I have a friend who is better than me, like in DevOps. I have a friend who is better than me in writing a Pythonian code, which is through visual poetry. Like
I need to stop you because we need to finish.
Yeah, sure.
Thank you so much for being a part of WIDS Subotica 2020.
Thank you for having me. I see a question about slides, and yes, slides will be shared. And if something was unclear, just text me, and I will explain in person. Cool. So bye-bye.
Okay, guys, thank you. I'm sorry, we sometimes need to cut off the speakers. Probably will happen again. Next speaker, Željana Grbović, is a young researcher at Biosense Institute and a PhD student in electrical engineering at the University of Novi Sad. She's highly interested in the application of machine learning algorithms and deep learning in the field of agriculture. She will tell us how data science, and in particular, deep learning technique, can be used in farming. So let's go to that talk.
Hello everyone, my name is Željana Grbović. I'm coming from Biosense Institute, where I work as a researcher. I'm also a PhD student at Faculty of Technical Sciences, University of Novi Sad from Serbia. Today I will speak about with ear detection and automatic counting in RGB and thermal images using deep learning. So what we're gonna do? We want to make from conventional and traditional agriculture, we want to make smarter, more precise production in agriculture. So data science very easily enter in different domains. The same case is with agriculture. So with available data from different kind of sensors, it is possible to make it smarter, more precise and connected production. This application would provide farmer to go in the field, take a photo of their crop and gain information about yield prediction of wheat. So the number of ears is one of the most important features that contribute to obtaining yield prediction. Today, conventional methods for yield prediction are usually based on previous experience of farmers. When we speak about science, the plant breeding scientists manually count ears within the frame of 1 square meter, and that number later extrapolate to the whole field. The both of mentioned procedure are prone to subjective evaluation, so these methods are just not sufficient precise. So using this application, the first benefit is to improve the efficiency of monitoring in crop management practices, to make it easier for not just for bigger producers but also for smaller ones. Also, manual work will be changed by the automatic approach of obtaining the ear density, saving more than 200 hours of labor, or when we speak about weeks, those are 2 weeks per location. Also, the very important thing is logistics. So with the information of yield prediction, it will be possible to make optimal decisions in warehousing logistics. When we speak about the monetary value, using this application will prevent a significant loss of investments from a potentially reduced yield. How? The farmer will have a chance to act immediately. So when he see the yield prediction at the moment of imaging, he can figure out that if it is below or it is average value for that growth stage of crop or for that season. So if it's not, he can act in a way of some treatments and try to save yield. On the screen you can see how we collect data from the field. We collect from 2 villages in Vojvodina, from Bajmok and from Ravno Selo, in 4 dates, in 2 growth stage of crops. First, beginning of flowering, when 10% of flowers of wheat are open, and the second one is early milk stage of wheat. Datasets consist of thermal images and RGB images. Both are collected by FLIR camera with 2 sensors. Thermal resolution is 440 by 480 pixels and it results in 1 channel image as color map, where it is possible to see differences in temperature between ears and background. When we speak about RGB images, the resolution is higher, but those images are also cropped to be the same size as thermal ones to make it easier maintaining in later steps. RGB is 3-channel images with 3 channels, red, green and blue. On the screen you can see examples. On the left side thermal image and on the right RGB. It's some kind of obvious why we want to show how thermal imaging can bring benefits in ear detection and in segmentation task. We first collect more than 3,000 of images, but outdoor image acquisition faced with many problems. At the first place, unpredictable weather conditions, weather, position of sun, angle and height of image acquisition, etc. So we decided to take a look into data and find images that are right, that are good, without blur. But you can see on this example, it could not be possible to find images without blur totally, because images were taken in perspective. So that's the reason why those years behind are blurred. So we chosen 138 of thermal images and 138 of RGB images, and later we divide the data set in ratio 4:5 for train and test the subsets. So after wisely choosing images, appropriate images, we needed to find appropriate labels. So we decide to manual label and make binary masks. On masks, white pixels belong to the ears and black belongs to the background. After we completed whole data set, named as WIDS dataset, then was time for finding appropriate architecture of convolutional neural networks. We made a decision to use these networks because it is wide known that this is the state of the art in computer vision, and that the deep learning is a solution with high potential and very, very good results. So we decided to make from scratch our network, and this network that we used consists of 4 blocks of 2D convolutional layers, followed by algo activation functions, a batch normalization and dropout layer in order to prevent overfitting. After finding appropriate architecture, we finally got detected object, in this case ears, in images. After that, we apply some post-processing steps as threshold to make results appropriate for applying next algorithm for automatic counting number of ears, and we used an algorithm based on connected components. When we speak about network performances, it's not just all about accuracy. F1 score is a widespread used metrics for segmentation, in case anybody of you didn't hear till now. So when we speak about model performances, we should take a look also in memory usage and required time for training. So we find out that using algo activation function, we can save approximately closely to 40% of memory usage comparing to other 2 parallel and ReLU activation functions. And also using this activation function, we can save about averagely ½ minute per training epoch. And of course that does not affect on model performances in a way of accuracy and F1 score and other metrics that we use. So how our model is accurate? When we speak about pixels, because this is the pixel-based segmentation, for thermal images our algorithm is accurate 92%, and when we speak about F1 score, it's accurate 75%. In RGB images case, 67 and 68 respectively. But these metrics, they are good, but they not bring us sufficient information about how we are accurate in a way of numbers of ears. So we decide to manually count the number of ears in images before and after segmentation and after applying automatic algorithm for automatic counting. So we find out that we lost only 3 ears per both kind of images. So here you can see a few circles. Here I would like to highlight what the problems in a way of image processing that we struggling and faced during this research. For example, first you can see that there are different size of ears on images. Also, when you can see 2 ears that are too close, that could mislead the algorithm to count them as 1 instead of 2. So, near occlusion and overlapping and different size of ears in images. Also, the huge challenge is outdoor image acquisition. So for the future work, we would like to improve conditions of the image acquisition. First, to adjust height and adjust angle of image acquisition. So last season we made a new data set. It's still in process. We collected images by smartphone and by gadget thermal camera, and we want to expand the database, not just to go every season to collect more data, but we want to give better version of application to farmers, to they give some feedback about experience, and also as a crowdsourcing to give them application to collect more data, and on that way feed our network, feed our model, and improve model performance. And also there is always room for improvement for architecture of network, and finally to get that prediction yield of WIDS. So we have some preliminary results that are not published yet, but stay tuned. We expect that soon we will have some results published in journal. So here on the link you can see what we published so far about this topic. So please take a look if you need more information. But also you can now ask some questions. And also I'm open for your suggestions, critics, etc. So you can write me on email or right now in chat. And what we published at the end, I would like to thank you for your attention, and of course, huge thanks for inviting me to organize it. Thank you very much, and I hope you find something interesting here, and stay safe. Goodbye.
Well, that was a nice presentation, and we should have Zhelina with us. Zhelina, can you turn your camera on, if you can hear me?
Yes, I hear you. Do you hear me?
Yes, yes. Just above, on the top of the window, there is a camera on link. Turn video on, above my head.
Okay.
Just...
I don't see.
Just like where you like
okay, here.
Exactly. Yay! Hello, Zhelina.
Hi everyone.
Okay, cool. So, whoa. I'm always asking people leave questions during the presentation. So I just got swamped with questions. So such a nice, calming voice, interesting research. Hope farmers will help you as much as you want to help them in the future. So that was one comment. So just
such a great comment.
So, how are you, Zhelina? Are you okay?
Yeah, I'm fine.
Fantastic. Do you plan to enrich the data set with some data coming from the sensor describing the soil?
Nice question. We first want to make it as much easier as possible, just to collect one type of data. Because if we collect different types of data, we maybe overload the algorithm and whole processing progress. So for gain information, we will have more seconds to reach the final information. So we want to make it as fast as possible. So this is a very good proposition or suggestion, but we didn't taking in consideration the types and features of soil so far. But in the future research, we can adding this. Thank you.
Fantastic. So the analysis of this big data would enable farmers and companies to extract value from it, improving their productivity. But what and how much farmers do need to learn about data science? Do you think it is important to them to be data literate, and how easy it is?
Interesting question for someone who is geek. So I would say that it's very important for them to learn something about data. But just to use the application and just to get information that is very important for them, such as yield prediction, they don't have to be data literate. But if they want to contribute to improve this application or to learn something more, I will suggest them to learn just about this application if they want to use it. What algorithms rely on, and etc. So it's easier for them to use it, but if they want something bigger, it would be nice to learn something about it.
Of course. So again, guys, viewers, ask questions regarding the presentation while you think about it, because everybody's just saying, what a nice presentation, what a useful topic. So just, so, you kind of circled it all. So I'm going to ask some like general questions. So did you always know that working in STEM related field, in particular data science, was what you wanted to do?
I always knew that I want to be in electrical engineering world, but data science is just jumped as a decision when I was on the last year in bachelor studies. That was the first time when I faced with the data science. So from there, I'm just fell in love, and that's it.
Cool. I'm gonna. We have one question that kind of is adjacent to the previous one. So, how hard is it to explain what a neural network is to a farmer? Valentina says her.
We usually explain that it's similar like a human eye, and then we explain what convolutional filters do as similar parts as perceptrons of our eye. So in that way, they just nothing, but I don't pretty much sure they really understand. But that is pretty much fine, because from a few months ago, the scientists didn't know how exactly neural networks work, so that's pretty much enough for me.
Okay, so Željana, what do you love about your job?
Working in science is interesting because you don't have deadlines as, for example, if you work some project in companies. But it's interesting because you put your under pressure on your own. So, of course, we have some projects that are connected with industry and companies, and that are usually short-term, so we do it. But when we speak about publishing, it's always pressure, because this is just the high topics, and very often somebody publish something that is maybe similar to you, so it's just like a race. So I like that.
Cool. Do you compare your work and results to some of USA or other countries' work in the similar field?
Yeah, now it's on rely would be the challenge worldwide known to in counting of wheat. So that was the first competition where I want to test my algorithm and to see how is accurate and how is good comparing to others. So also in collaboration with the University of Strathclyde and the Agri Epicenter from Scotland, through Dragon project, we will test this algorithm on other types of crops, on barley first, and on their wheat, that is other species of wheat. So we're gonna see from different sources how this algorithm is really good.
Well, what a fantastic presentation and what a fantastic flow. Everybody's just praising you. So I'm going to ask one last question. What advice would you give to your younger self What would you do different in getting into data science?
Be braver and not so shy in expressing your first results.
And a great suggestion to all of you viewers. Željana, thank you very much for being with us at WIDS 2020 Subotica Online, and what a great presentation. Thank you so much.
Thank you, all of you.
Okay, guys, next up is Bojana Soro, who is a data analyst at Content Insights. She has a master's in applied mathematics. She has studied financial mathematics at the University of Novi Sad, and she deals with data visualization, lab research, big data, mathematical modeling, statistics, data analysis, and optimization. So she will illustrate the application of data science in digital publishing industry by the possibilities of monitoring content performance through different dimensions using machine learning techniques to gain some valuable insights. Enjoy the presentation.
Hello everyone, my name is Bojana Soro. I am data analyst at Content Insights company. I have studied financial mathematics at University of Novi Sad. My field of interest is data science. Today, I will talk you about content intelligence that informs content optimization. Every organization is realizing that in order to maximize their benefit, they require the magic of data science. Data science is shaping the new world where data is the necessity of the industry. It is becoming the most popular field across the globe because of its numerous applications. If you look at the world, it is totally digital, and big data giants like Google, Facebook, Amazon, and thousands of many more consume the global economy, and all of them use data science, machine learning, or artificial intelligence. Data science becomes one of the most demanded jobs in today's digital world. Nowadays, there is no industry in the world that does not use data. This presentation will focus on data science application in digital publishing industry. So, what we do? Content Insights is a startup company that's developing the next generation web analytics services for evaluating content performance. Our mission is to help online publishers and content creators make sense of the amount of data and how to truly understand their audience without data analysts. We help them understand how to increase revenues without resorting to clickbait, how to grow without yielding to fake news. We want to fix online content space by empowering content writers to create quality stories, reach audience, and make sustainable business without clickbait titles and fake news. And how we do it? We do it by introducing people behavior metrics instead of browser matches. Online content is consumed by people, not browsers. To be able to work on our mission, we created an algorithm called Content Performance Indicator. It showed how well a certain piece of content is performing in comparison to other published articles on that particular website. Content Performance Indicator explains what drives readers' behavior and gives insights into how certain piece of content resonates with the audience. Content Performance Indicator takes into consideration dozens of different content performance metrics and examines their relations. It also weights them differently according to three behavioral models: exposure, engagement, and loyalty. We do hard work of making connections and putting different metrics in context, noticing patterns and driving meaningful insights in order to make our clients' decision-making process easier. Content insights assist the whole newsroom in making data-informed decisions in the fast-changing industry. To achieve our goals and mission, we use data science. Today, I will present you one simple machine learning algorithm called clustering. It is basically a type of unsupervised learning method. Unsupervised learning method is a method in which we draw references from data sets consisting of input data without labeled responses. Generally, it is used as a process to find meaningful structure, explanatory underlying processes, generative features, and grouping inherent in a set of examples. Clustering is task of dividing the population or data points into a number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to data points in other groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. The most commonly used clustering method is k-means. To explain concept of k-means method, I will use one simple example. Imagine you are opening a small bookstore. You have a stack of different books and 3 bookshelves. Your goal is place similar books in one shelf. What you would do is pick up 3 books, one from each shelf, in order to set them for every shelf. These books will now dictate which of the remaining books will go in which shelf. Every time you pick a new book up from the stack, you would compare it with those first 3 books and place this new book on the shelf that has similar books. You would repeat this process until all the books have been placed. K-means algorithm works something like this. K-means clustering is a good place to start exploring an unlabeled data set. The K denotes the number of clusters. The algorithm is bound to converge to a solution after some iterations. It has 4 basic steps. First step is initialize cluster centroid. Second step is assign data points to clusters, then update cluster centroids, and final step is repeat step 2 to 3 until the stopping condition is met. There are some results. The first chart represents 4 metrics. We have article reads, unique visitors, new visitor, and social actions. This result is without applying clustering algorithms. On the next slide is bar chart, but with applying k-means algorithm on articles. We have 3 clusters. There, the articles are separated by article length into 3 groups: short articles, semi-long articles, and long articles. We can note difference in metrics depending on the article length. So we can see that all of these 4 metrics are the highest by long articles. And these lines representing trend, and we can see that we have growth in all of these 4 metrics. In the next level, we can compare free and paid articles. Again, we observe same metrics, and articles are separated by article length. But in this segmentation, we can compare performance of articles depending on article type. We can conclude that paid articles have higher value than free articles. Also, we can compare distribution of number of articles depending on article length. On the left side chart, we have distribution of free articles. It is clear that almost half of free articles are short articles. On the other hand, chart on right side shows totally opposite distribution in paid articles. Here are dominant long articles, and while number of short articles is very low, only 6%. So distribution of free articles and distribution of paid articles are completely different. From these few examples, we can conclude that results with clustering have more informative approach than results without clustering. And for the end, I will conclude with K-means advantages. What are advantages of K-means algorithm? Relatively simple to implement. You can implement this algorithm in R, in Python, or any other language. Scales to large data sets, guarantees convergence, and that is very important that when you have algorithm, that you have convergence. Can one start the position of centroids, easily adapt to new examples, and generalize to clusters of different shapes and size. With advantages of K-means, I conclude my speech. If anyone has any questions, please feel free to ask, and I will do my best to answer. Thank you so much for your interest and for your attention, and thank you so much for listening to my presentation.
Well, hi everyone, welcome back. We're just waiting to see if Buena can connect. We're gonna give her a couple of minutes. Okay, just 1 second. And she should be with us in just a moment. So I'm gonna ask everyone to please just keep your mind, ask questions while the presentations are going, and so we can have questions prepared. Buena, hi, welcome.
Hi, thank you.
So good to have you here on WIDS Subotica Online. Thank you so much for your presentation. It was awesome. Okay, so I love your company. Okay, so I have one question right out of the box. Have you considered any other algorithms for unsupervised classification, and if so, which?
We can consider other algorithms, and it can most algorithms to cluster and to clusterization. But in this presentation, I explain K-means. But you can choose something like hierarchical clusterization or tree clusterization or something like that. There have many options, but in this presentation, we choose these K-means algorithms.
Okay, how often do you perform model retraining for your type of the problem?
It depends from case to case, but we can do this when it had the need to perform that.
Okay. Do you analyze the inside of the text, for example, topic, frequent words?
Yeah. We analyze this in 4 segments. We analyze sections. We analyze topics, articles, and authors from these articles. And from each of these segmentation, you can compare your results, and you can find analytics for each of them.
Okay, what was one of the challenges that you encountered with working with publishers?
I work in labs team. My colleagues from Success work more with customers, but I think that it is a big challenge to explain them these numbers. What does it mean in actually?
Are there any other behavior metrics we can use? This is mostly click data, if I'm not mistaken.
Yeah, we have metric, our metric, that is article rates, and that is not like page view. Page view is only when you click on the site, and our metric article rates is when you click on the site. 10 seconds later, you got this metric.
Okay, so while we wait for other maybe viewers to ask any questions, so what do you think are the most effective ways to make the case for diversity in an organization, and what strategies do you see as key for developing innovative and diverse teams?
Mm-hmm. In my opinion, the most effective way to make diversity in one organization is to think about diversity from the start of the process and address all the aspects of the diversity. And it is very important to celebrate differences between team members. And second part of the question about strategy, I think the key of developing innovative teams is in having people who are different age, different gender, different backgrounds, and that's developing innovative team, and that bring you new ideas, achieving your goals and success, in your company or your organization.
Okay, Bojana, we have another question regarding the presentation. So what's different from example GTM events like scroll, time on page, clicks, copy texts?
Excuse me, can you repeat?
What's different from example GTM events like scroll, time on page, clicks, copy texts?
I think I should think about it, but
okay, we can leave it for another time, or you can contact Bojana directly after the webinar, and she can answer more elaborately. Do you monitor readers' activity around text, for example, whether they've come to it from another content at the same site, whether they leave or stay?
Yeah. We can track all of these activity of readers, and we do this by user cookie, and we can check when reader go to the site or to articles, how read articles, how deep read articles, that only click article and then close, or read total articles, or read a part of articles. We can do all of these with
fantastic. So for the last question, what advice would you give to someone looking to grow their career in data science?
Great question. Because in my opinion, it's the most important that you love that your job, and that you enjoying doing your job. After that, that is important, which field of data science you are preferred. That means that you could find your area of data science. That could be data analysis, data engineering, machine learning engineering, or something else. When you find your field of interest, it is very important to everyday learning. Every day learn something new knowledge, new programming language, new algorithms, and every day learning something new. And when you start with data science, it is my advice is to begin from something that is simple, from simple concepts, simple algorithms, and it is important to understand the essence of concept, and then you will be able to upgrade your knowledge. And my suggestion is good luck and go ahead.
Fantastic. Bojana, thank you very much for being with us at WIDS Subotica Online. Glad to have you. What a fantastic presentation. And please join us back to watch the webinar. I'm going to link you a question that we could not answer, so you can answer in chat. So cool. Everybody, we're going to the next presentation immediately. Next is Tiana Blagoyev, who holds a master's degree in politics, big data, and quantitative methods from the University of Warwick. As an R enthusiast, she will focus her talk on the application of programming in R for media policy development. So good luck. Let's check out her presentation.
Hello, my name is Tiana Blagojev, and I will be talking to you about programming in R as a tool for assisting media policy development. First of all, let me give you a little bit of background about myself. I'm currently working as a program assistant at the Media Department of Organization for Security Cooperation in Europe in Serbia. And we are following developments in freedom of expression in the country, organizing training for journalists, and providing support to establishing adequate media policy. Also, I have an MA degree in politics, big data, and quantitative methods at the University of Warwick, which I got through Chevening Scholarship. This was an opportunity for me as a person with no computer science background to learn quantitative analysis and programming in R, which was a great experience to have. I'm also one of the co-organizers of Our Ladies chapter in Belgrade. And for those of you who are not familiar with, this is an organization that promotes gender diversity in our community through different trainings, workshops, lectures, mentorships, and I have been giving lectures both in UK and in Serbia. Let me give you a bit of general idea of what media policy development is and what me and my colleagues do. So we are monitoring implementation of media legislation. We are assisting academia in various researches and supporting them in developing programs for journalism students. We are supporting various analyses on media situation in Serbia that can be baseline for changes in media policy. And finally, we are providing suggestions for improvements of media laws. During this process, I noticed there was a lot of data gathered, and I was thinking if one would present them visually or do some analysis, this could contribute even more to the media policy development. And that is why I started searching for MA degrees that would allow somebody with non-scientific background to learn programming, and that is how I met R. And why I love it? It is because it is an open source, because it is a good programming language for data analysis and visuals. It has a great community that allows people to connect, to solve many issues, to exchange ideas. It is a subjective thing, but for me, R and R Studio are very intuitive. And knowing R can help you learn more easily other programming languages. R comes with different packages, which are bundles of code and functions for specific purposes, and I will talk to you a little bit about Shiny, the package used for developing web apps, and our Markdown, that is Flex dashboards that is used for creating dashboards with different visuals. And I will show this to you through two examples. One is government funding of media in Serbia, which was my dissertation topic, and the other one is a test version for research done by media expert Nedim Sedinovic on media that are providing information in minority languages, again in Serbia. So let us go to the first example. This is a web application of data on project-based co-financing of media content in public interest. And now you must feel something along these lines. So I will actually simplify it and say that it is a government financing of media through projects. So let us go and see how this web application look like. This is data gathered by Ministry of Culture and Information through the process of media strategy development, and it was in Excel spreadsheet, and it covered year 2015, 16, and 17. I received this from Independent Journalists Association of Vojvodina. I was thinking maybe it would be good and user-friendly if instead of Excel spreadsheet, one could more easily look at how the funds were given to by different municipalities, to which media, and how much of that money was given to them. So you could see all this information. This information is actually in British pounds. You can see how much, who gained the most money, like RTV Novi Pazar, for example. And also you can go and take a look at a particular municipality and see how the funds were distributed through years, or search for in this corner, upper corner, right corner, like for example Radio Far, and see how much money it gained throughout years. This is actually a very good thing because, first of all, it supports open data initiatives. This data at the moment is not publicly available, and it would be really good if they were. When it is publicly available, it can be validated by journalists, by media experts, and the errors, mistakes could be corrected. If Ministry of Culture, for example, would be interested in taking on this web application with minimum of training and filling in of data in Excel spreadsheet, they could easily update it for the coming years. It can better target trainings in case some organizations are doing trainings, they can see the distribution of funds regionally. It can be also good for supporting legislative changes and improving the entire process. And finally, public themselves can provide evaluation of the process, because in their own local communities, they know this media, they know how the programs look like, and whether they fulfill public interest or not. The second thing is I will talk to you about R Markdown, a reproducible research. R Markdown is a package within R that is combining code and text and results of your work. It is very good because you can follow somebody else's work, and somebody else can follow your own research and then can contribute to it more easily. And you can with it develop documents, websites, books, and dashboards that I will now show you. So, as I already said, this is a test version of the data gathered for a research done on media that are providing information in minority languages. So let us again see how this looks like. I'm apologizing that it is in Serbian, but still you can see in a nutshell, this is the number of minority media, general information about the project. This is the number of media for a particular language, like Hungarian, Roma, Slovakian, Albanian, and you can see where these media are geographically. And if you are, for example, interested in a particular media, you can get more information. Usually for radio, TV stations, you will see the information from the regulatory body for electronic media, or in case there is no information, like for example I think this one, you will get that there is no online information about this media. Another good thing is that you can get different tabs with tables, additional information, contact email address. But the good thing about Flex dashboards is that you can actually connect Shiny and Flex dashboards for more complex things. For example, I will now show you the exactly same website, but you can here download in CSV or Excel file the data that was gathered. And this is great because this allows your research, first of all, to be in a way used by others for their own research. They can also, in consultations, contribute with correcting your own work because it is public, it is actually transparent. And this is a simply great thing to do. Another advantage is that it is a kind of a storytelling thing. It allows audience to get more engaged, and it is an interactive presentation. And I know that usually media policy topics sometimes can be some daunting and not very attractive to general public, but with this you get more engaged, more interested public and audience, and maybe proactive. And also you can use these dashboards not only in the media policy area, of course you can use it in finances, project development, monitoring of expenditure. Literally the sky is the limit. And why do all this? Because in the era of disinformation and fake news, data literacy is very important for people to know, to understand the use of graphs, proper use of graphs, and also basic statistics, and they can learn this along the way. Interdisciplinarity, by knowing skills and knowing R, you get acquainted with people of different, diverse backgrounds, and this can actually have an influence on your own work. And spark many ideas and collaborations. It is, as I already said, efficient and reproducible research, but also it allows you to have a skill that can make your research more publicly available and more attractive to be followed and read. And transparency and openness I already stated, so the importance is there. And finally, for journalists themselves, they can actually accompany their articles with these, and at least have again attract more audience and have more engaged audience, and maybe hopefully at least to a small extent help their sustainability. So I hope that I did not overwhelm you with too much information in my lecture. I hope you found it interesting. Here are some additional resources that you might find useful about Introduction to R, about Flex Dashboards, Shiny, as well as some examples of my work. Yeah, well, this is the first and last time I will be together with Keanu Reeves, but since this is a screenshot of my presentation, I thought maybe you would like to see how I look like and say hi to me in the street. Anyway, thank you for your attention, and I'm looking forward to the questions you might have.
What a fantastic presentation, Tiana. Good job. Tiana is with me. You can turn on the camera, Tiana. It's just here above my head. So, and also the mic, if you can hear me. Awesome questions. We have loads of questions to you. Tiana, are you with me?
Can you hear me?
Yes, I can hear you. The video, turn the video on, is just about like where I'm pointing, somewhere above my head.
Yeah, it is not allowing me to turn it on for some reason. Maybe it's a connection problem here. It's a real thunderstorm outside, so I'm not sure. It doesn't allow me to.
Okay, so we're gonna do audio, and that's the most important part. So to the viewers, Tiana is still with us and can answer questions. So I'm gonna dive right in. Tidyverse or base R?
Oh yeah, that is a very usual question to ask. And since in academia, when I was studying, they were saying to us never to use ggplot2 and always to use base R. As soon as I graduated, I decided that tidyverse is something that I want to do more. So maybe for others would be base R, but for me, tidyverse definitely.
Okay, is there any possibility for those data sets to be released in open data format for journalists to validate?
I completely agree. That is a great question, and that is one of the reasons why I started doing this, because we are doing this media policy changes and hoping that they will open these data sets. So I really hope it will be possible, and with showing this, what can be done, and even the ministry to participate, maybe that would urge them to open them so that journalists can validate, because that is very important to do.
Oh, fantastic. I completely agree. I also find it fascinating. So I want to see just the information, not the data science. So how difficult was it to jump into R and programming, going from zero to hero? Do you have any advice for someone who'd like to jump in as well?
Yeah, well, I know it can be daunting, and I can understand that completely. But I was really enthusiastic about it because I like to see how data can be visualized, and that was some kind of a urge for me to do these kind of things. And if anybody has interest in it, I would suggest either to see our studio blogs and stuff, or also to check if they are journalists or interested in mass communications. There is a great book, Practical R for Journalists and Mass Communications, but by Sharon McLeese, because these are kind of things that can help in different areas people to understand the topics and then understand how to connect programming language to these topics. So with that, I think it is more friendly to start from zero and to become a hero, though I'm not sure whether I'm to that stage now.
Do you do sentiment analytics in R? And if so, do you translate Serbian to English? If not, what is a drop in accuracy?
Yeah, I don't do that. I think it's a great thing to do, but I have to say there is a pinch of salt to think about it, because sentiment analysis as such depends on wordings and texts, as far as I understand, and some things are not built that way. So I think some professionals, apart from people who really do know how to do sentiment analysis, should work together to sort these kind of things and make sure it is proper and appropriate to publish it, for example.
You have a comment.
Mm-hmm.
I'm hearing myself double. You ladies are amazing. What actions and from whom do you propose for educating journalists and media experts in benefits of open data, data literacy, and importance of better data visualization in newspaper and media portals?
I just didn't quite catch the beginning.
What actions and from whom do you propose for educating journalists in this?
Well, yeah, I would say the OSC does provide trainings, and also sister analysts do certain projects related to support to journalists. And I think that would be like a starting point if somebody would like to do, or they can contact me as well. I can make sure that they can get in touch with the proper people to do this. I think that's a great idea. That's something that I'm very enthusiastic about, to provide this to them.
Okay, so a question that where do you publishing Shiny apps like shinyapps.io, or do you deploy Shiny server on some cloud service?
For the time being, shiny.io.
Cool. What packages do you find most useful?
Tidyverse, but also sometimes I like. I mean, of course, Shiny, R Markdown. R Markdown, I think, is maybe very good to be included in academia because it allows your research to be reproducible. I know it is a kind of a difficult thing to involve people to do this, maybe in Serbia especially. But I think if there are people who are interested in doing some kind of things, they can only contribute to better researches and more collaboration.
Well, you just answered all the questions from viewers, and we're out of time. So, Tiana, thank you so much. It was an awesome presentation, and thank you so much for being part of WIDS Subotica 2020.
Thank you. See you. Bye.
Okay, guys, we have one last presentation. It's Maria Knorps, also from Poland. And Maria is a data scientist, sorry, my English is slipping, creating analytics, BI, and machine learning solutions from the data collection to the web development. She will explain to us challenges of small data, from gathering data in an unified way and data cleaning to ever-baffling challenge of modeling sparse data. Now, you should be aware that Maria unfortunately called us and told us that she cannot attend the live event because of some urgent matters, so she will not be here for the Q&A session, but stay with the presentation, and after the presentation, we will hear from Tatiana Kecevich, who is the organizer and who collected all these 5 ladies. So we go to Maria's presentation.
In data science, we often walk in the realm of big data. Today's talk will be on challenges of small data. There are many companies that gather data for years and it still does not exceed few dozens of megabytes. The information and business supporting insight are still there, but we have to find a way to extract it, and smartly, because there is not much to extract from. Today I will describe challenges in dealing with small data on example of perfume industry. Our client is a perfumer. They sell their fragrances to cosmetic companies, which order fragrances of specific characteristic, for example, fresh and citrusy, and of course the fragrance should be well liked by people. And how does a perfumer can check if their fragrance is well liked? They order market research, where individual clients tell if they like the fragrance, if they had the proper attributes, and why are we needed in there, why that data science is needed there. We can assist with constructing fragrances that are better liked by people based on historical data. We can also help to find some ingredients that do not have any impact on liking or any other attributes of fragrance, and this costly. So it could be a cost optimization of perfumes. Usually customers' data consists of 3 parts. It's customer tests, aggregated tests, and formula ingredients. Our goal is to find which ingredients should or should not be included in the fragrance to fill the requirements of the cosmetic company. So the main goal is to find data that connects the customer tests and formula ingredients. The challenge is the amount of data there. The client thinks that 500,000 of Excel lines is a lot, but in fact it is not, because it aggregates to 1,000 customer tests. And formulas, we usually have around 300, 400 of them. So the data is really small, but still we can say some interesting things about it. We will, in further slides, we will decompose the graph that is presented here and see which part generates what obstacles. Let's start with customer tests. The data in customer test is, of course, test IDs, so we have to have a way to identify it. Respondents' characteristics like age and gender and place of stay, and impression of fragrance, liking, strength of fragrance, buying intention, attributes that fragrance possesses. And customer test may be done in several methodologies. One is a typical one is triangle test, where each person is given 3 samples. One of those samples is a benchmark, so it's a well-known perfume which has similar characteristic. And customer need to say if they like the fragrance or not. Second type of test is pair test, where 2 samples of different fragrances are compared. And Monadic Test is the third one, where only 1 sample without reference is tested, and this one is usually done for new fragrances, some totally new ideas. And for the triangle test, we also have to be very aware of if the test is done correctly, because people tend to say that they like the first thing they smell. So in here you see the dependence of liking. The higher the liking, the people like it better. On order of testing, it's the same perfume. So if it was tested as first, it gets considerably better liking, like around 4, than when it was tested as a second or third, because then it's almost all of the people say it's 1, so they really don't like it. And another challenge is normalization. For example, we have 2 scales, from 1 to 5 and from 1 to 7. First scale was used to score strength of perfumes in years up to 2016, and from 2017 they use from 1 to 7. And right now, if you want to compare the results between those years, we have to normalize it somehow. But the normalization of scale, even if it's ordered, it's not that straightforward. Maybe for statistics like mean or median, it will be okay. But for statistics like top box, where top box is the percent of people who gave the highest score, it's not straightforward match between top box 5 and top box 7. The solution in here is to consult with the business and to understand how people would behave. How should we match those 2 together? Another challenges in customer data is formula ingredients. The client may give us the formula ingredients in encoded form, which is for his safety the best way, because they do not give us any secrets of the company. On the other hand, when they give us explicit formula ingredients, we can see some discrepancies and we can maybe find if the data was collected correctly. The example we have is we had several perfumers working for one company, which have the same program they exported the data from, but the export preferences might be different, might have been different. One of the perfumers grouped their ingredients and the other did not. And if the formulas were encoded, it would not be that easy to find if there was a difference in export. The same problem, maybe a bit similar, is when the ingredients are named in similar fashion. So there is a one core name and, for example, 0.1, 0.3, and other different ends of the name of ingredient. Sometimes those mean the same ingredient, but just the name is different. And this can be found when the names are explicit. From this one, we've learned that you should check consistency of data and each and every step because even if everyone thinks it's clean and it will work, better check. Another challenge with ingredients is that number of ingredients, it's over 1,500, and only for less than 10 formulas we have 1,200 ingredients. That means that 1,200 ingredients, you may find them in less than 10 formulas, so the matrix is very sparse. So there is a lot of uncommon ingredients. It will not be that easy to capture their importance in the fragrance impact on customers. And another part is the matching. Finally, we use aggregated tests and formula ingredients. But even there was challenges, because in aggregated data we had several candidates for key of the match. There was internal code, internal name, and code. On the other hand, for formulas we have only code. But how did it look? Internal code and internal name, they seemed a bit similar than the code they should match in formula ingredients, but they did not match. We could use very special rules for matching, but it would be inefficient and error prone. That's why we had a lot of conversation with client to better export the data so it would match better, and we created data dictionary that for each of those tables, so customers test, aggregated data, ingredients, they describe which column indicates what part of the business. Unfortunately, we could not well match customers' tests with aggregated data. Customers' tests were on very detailed levels, so we could have more information from it, but to match aggregated data and ingredients was enough. And yet another part of our experience here is that apart from data dictionary, we also create data map based on that. So we know exactly which part of data should be matched with which part of in other tables. And we also learn to avoid special cases. So if we see that the match is okay, but some of the cases, well, maybe not that good, we try to find the general rule and not implement special cases. Our tech stack for these projects was Python and Vue for data analysis and visualization. We used Haskell when reliability mattered. From databases, we used Elasticsearch and MariaDB. One is NoSQL and another is relational. And we also experimented with data version control, DVC, but we did not like it, at least not for data cleaning part. And just to summarize, documentation, good exploratory analysis, and communication with a client can help you face the challenges of small data. Thank you very much.
And we're back, and the final presentation is over. And for the end, I'm sorry not to have Maria, but I have Tatiana Ketsevich. Hi, Tanya.
Hi, everybody. Hi. Hi.
So, Tanya, thank you for organizing and bringing these 5 fabulous ladies together to give us such awesome presentations.
It was a pleasure. I really have to thank to all the presenters and especially InfoStud for giving us the support we really need. And thank you very much, Jaiko, for helping us organizing this.
It was my pleasure. So, Tanya, what are some of the plans for women in data science in Serbia over the next period?
Well, we are trying to connect regionally, and we are already connecting with WIDS Croatia, with Sarajevo. So hopefully, watch for the space, and we're gonna have bigger and greater events in the future in the region.
Cool. And what about our ladies?
Oh, our ladies are going strong. We have 2 chapters in Serbia, one in Belgrade, one in Novi Sad, and there is an opportunity to start our ladies in niche, but as with everything, like often women find difficult to just break the ice and step into the scene, but I'm hoping the girls down in niche will do it.
Okay, so do you have a closing message for everybody viewing?
Yeah, I would like to say, well, wow, it's been truly thought-provoking 2 hours for me. And thanks to all presenters, you have done an outstanding job sharing with us your valuable knowledge, insight, and experience on how to empower women in data science field. Thank you very much. This year, we were aiming to gather a number of women in data science, not just from Serbia, but to connect regionally. We were also intending to engage with young women still attending local universities. However, despite not being able to go ahead with our originally planned program, through this online event, we have managed to bring together a number of inspirational women directly engaged with data science within the region. It has been certainly motivated and galvanizing, and we should build upon this to create a stronger regional community within the global WIDS. It will provide us with the opportunity to outreach to women and young girls in more remote places within the region. I'm so sorry, I have a little girl who's just turned the TV on. That's what happens when you women.
It's not a problem. Yeah.
So really encouraging, inspiring, and empowering women, it's what Women in Data Science stands for. And let me once again express my sincere thanks to all of you for coming and for contributing to the discussions. And really, finally, it's time to officially close with Subotica 2020 conference. And I sincerely hope that we'll meet up next year in greater number and in happier circumstances. Thank you all.
Fantastic. And what a great closing of the event. Hi there. Hi. Okay, so we have a very nice closing. Tanya, thank you so much for organizing the ladies, and ladies, thank you so much for the presentations, and to all viewers, thank you for being with us on this WIDS Subotica 2020 online edition. We will see you on the next webinar, on the next event, and stay close.
Thank you, and see you next year. Bye.
Bye.